Okay, Assalamualaikum and very good morning. Okay, today we are going to learn about the new topic for the chapter number 2. So, boleh nampak tak skrin saya? Can you, boleh?
Macam
Belum
tak
lagi
ada,
eh? Okay, tak apa,
tak ada
relax.
dia.
Okay, kejap ya. Sebaik saya tanya. Okay, Assalamualaikum and once again, okay, very good mornings. To all my students, especially for the industrial engineering. So this is BDA 40703. So today we are going to learn about a new topic for the chapter number 2. So this is chapter number 2. The topic will be on the facilities plannings. Okay. Okay, let we begin. Okay. Okay, this is a learning outcome. Okay, for our topic today. So the first one, you'll be able to determine what the facilities location in the cost in effective way. And number two, you are able to discuss what are the basic layout designs with these advantages and disadvantages. And number three, we are able to propose a simple process layout for the manufacturing and service industry. Okay. Okay, this is the definition of the facilities. What is facilities? Facilities is a building structure, okay, what we call it a fixed assets, and resources that support the operation management of the manufacturing or service activities. So facilities will be involve the humans, money, material, energy in the activities. Okay, so this is facilities. We known as a fixed asset. Okay. And then this is example the facilities. So if we are in the production line, so this is discrete part industry or process industry. So in the healthcare is the hospital or clinics. In education is a school, college and university. And also the food restaurant, fast food place or banquet halls. And commercialized is residential is a shopping malls, office building, bank, houses, hotel and motels. And if in the government or public sector is a courthouse or post office, and transportation, airport, train station, bus terminals, public assemblies such as a stadium, auditorium, or theater, and religious is a mosque, temple, chapel, and church. This is what we call it facilities. Okay, this is facility. This is example. And facility planning divided by two types. The first one we have the facilities location. Okay, and second one is the facilities designs. So what is the meaning of facilities locations? Okay, the place to locate the facilities. Okay, and this is facility design or what we call it facility layout. The way to arrange the element in the system. Okay, such as a machine, manpower, material storage, or manual handling systems. Meanwhile, for the facilities design has been divided by three. Okay, that we known as the structural designs, layout designs, and handling system designs. So the structure design include the building and support facilities such as the water, power supply. Meanwhile, for the layout design is a space requirement for locating the resources. And then last but not least, the handling system design. Handling system design is more on movement of the material, people or products. Okay, so this is the facilities planning concepts. So divide by two, location and also the designs. So what is important for our facilities planning? Okay, first one, we want to minimize the waste due to the efficient material handling system or MSH. Okay, and manual or material handling system involve 20-50% operating costs in the manufacturing. So the effective material handling system can be reduced about a 10 or 30% cost. And then we want to minimize waste due to the long-term plan. Okay, so expandability, flexibility of the industry, okay, environmental implication, hazardous waste disposals, and safety, convenience or appearance, influence worker morals. And last but not least, the importance of the facility planning is we want to the lead to the economic developments. So this is a benefit for the important for the facilities plannings. And when we are determine the facilities location, when we want to identify the facility location, okay, first one, we want to identify the location is based on 4 criteria. Okay, the first one, when we are starting a new business. Okay, and number 2, we want to enlargement in our business. And number 3, we want to centralize of the operation. And number 4, we want to other economic purpose. So this is the 4 criteria when we want to identify the facilities location. Meanwhile, what are the factor influence for the identifications? The first one, this is factor influence in order to identify the location. Okay, the first one, we must close to the market and source of the materials for easy for conduct our material or facilities, and labor availabilities. Okay, geographic area for transportations, social acceptability. Okay, especially for the hazard control. And last but not least, we have to look at on the our state law or procedure. So this is a factor. So we have a 5 factor that influence to identification of facilities. Okay, and how we want to select the facilities location effectively. So there are many methods in order to determine the facilities location. So in this topic, okay, we only focus 3 type of the calculation. Okay, the first one we call it as a location break-even analysis, or we call it a BEA. Okay, so please write down first. And known as a cost profit volume analysis. Okay, this is number 1. Okay, number 2 we call it a mini sum. Mini sum models. And number 3, okay, we call it as transportation methods. And the others method include the assignment technique, factor ratings, or center of gravity methods. So in this topic, okay, for the undergraduate study, so we only focus 3 type of these calculation in order to determine how to select the facilities location effectively. So the first one we have a BA, the second one is a mini sum, and last one we call it as a transportation methods. Okay, so this is topic very important. They also have a theoretical and also the calculation. So we look at one by one. Okay. Okay, this is the first one. We call it as a break-even analysis, the number 1. Okay, I need all of students please copy down this formula first. Okay, just a simple formula. Okay, TC, okay, equal to the FC plus the VC times to the Q. So what is a TC? TC is a total cost. Okay, in order to find a total cost, okay, we need to find a FC. FC is a fixed cost, not fan club, fixed cost. Okay, so fixed cost is constant cost regardless with the output level. Okay, such as land, property tax, insurance, equipment, or buildings. Meanwhile, the VC, VC is stand for the variable cost, okay, per unit Q. So varies directly to the production volume, okay, such as labor, materials, transports, and variable overheads. Meanwhile, for the Q, Q is a quantity or volume of the output. So this is a formula in order to calculate the total cost. So TC is a total cost, right? Okay. So please copy down total cost. Okay. So please remember the formula. Okay, this is simple formula. The total cost equal to FC plus to VC times to the Q. Okay. This is a formula, very simple. Okay, how we want to determine the BA or break-even analysis? There are 3 type of the steps. Okay, The first one, we have to determine what are the fixed and variable costs associated with the each location alternative. Okay, the first one, we have to determine what are fixed costs and what's the variable cost first. And number two, we want to plot the total cost line for the all location alternative on the same graph. Uh, so the fixed costs are constants. Please remember, for the range of probable outputs. Meanwhile, for the variable costs are linear for the range of the probable output. So the requirement level of output can be estimated. So only one product is involved. Okay. So later on, I will explain to you the details. And number three, okay, last but not least, we have to determine which location will have the lowest total cost for the expected level output. So please remember there are 3 steps in order to calculate or to determine the break-even analysis. Okay. Uh, okay. Look at on the example first. Okay. This example that given to you. Okay. Okay. The formula not given in the our examinations. So please remember. Okay. They are given to you. This is a community. Okay. A, B, C, and D. And they're given to you a fixed cost, okay, per year, and also the variable cost per unit. And then you have to find out what are the total costs, okay. So this is a fixed cost. Please remember FC. Uh, this is variable cost, VC, and they're given to you for 20,000 units. This is what we call it as a Q. Uh, okay. So the question is going to be like that, okay. So when you have to calculate the total cost, okay, total cost will be focused on these things first, the fixed plus variables. Okay, so please put it on this formula first, okay, in order to calculate the total cost. Okay, so please double check, take out your calculator, okay, and then let's say this is FC, okay. This is a VC, variable cost, and this is a Q. Okay. So in order to calculate, please apply this formula TC equal to FC plus VC minus times 2 Q. Okay. So is it the correct answer? Total cost. So double check again. Okay. So you will get the number. Okay. So this is very simple. So just apply this formula first. And then after you get all these things, okay, so you have to plot a graph. In x-axis, okay, please put on the Q. Q is 1,000 of unit, okay, so thousands. Meanwhile, for the y-axis, okay, so please put the annual cost, okay, the thousand of the dollar. Okay, so this is Q, okay, 2,000, 4,000, 6,000, 8,000. Okay, this is based on the thousand of units. Meanwhile, for the annual cost is thousand of dollar, 200,000 of dollar, 400,000 of dollar, 600,000 of dollar. So we look at on the our back. Okay, so this is a fixed cost. Okay, FC, and this is total cost that we get TC. Okay, very clear. Okay. Any questions so far before I proceed to the next? Clear? Okay. So please remember x-axis, you have to draw the Q, thousand of the unit first. Meanwhile, for the y-axis, annual cost, 1,000 of the dollar. Okay. So how we want to plot the graph? Okay, for each our community A, B, C, D. Okay. So in order to plot the graph, so make sure, okay, we starting on x1, okay, equal to 0, okay, x2 okay, equal to 20. Why we need only take a 20? Because this is thousand of the units. So 20K or 20,000 of the units. Meanwhile, okay, for our fixed cost and total cost, okay, that will be Y1, uh, and total cost will be Y2. Ah, okay, please remember. So in order to plot a graph, okay, the point for the A, so you must to mesh x1, y1, x2, y2. So let we go on the first plotting. Okay, line A first. This is line A. The first thing, you have to draw x1 is 0. Which one x1? Here will be 0. Okay, this is 0 line here. Okay, 0 lines. Okay, and y1 will be 150,000 of dollar. So which one 150,000 dollar? So the point will be here. So we can bracket here 0 or 150 here. X1, Y1 first. Okay, please remember X1, Y1. Another point, okay, we have to plot here. Uh, X2, Y2. So X2 we will get 20. Y2 we will get 1,390. So X2, Y2. So plot here and plot here, make it a linear line on the line A. Okay, clear? Okay, so same goes to B previously. Okay, for the B, please plot x1, y1. So x1 will be 0. X2, y1 will be 300s. So 300 will be here. So 0 and 300, for example. Okay. And then we mesh with the B. B also x2. Okay. Y2. Okay. So please refer to our fixed cost and also the total cost. So against, okay, please remember x1, 0, x2, 20. Y1 and Y2 is based on our fixed cost and also the total cost. This is how we plot the graph, okay, and draw the lines. And same goes to the B, C, and also a D. So just plot the graph, okay? Then finally you will get this graph like this, okay? Uh, any questions so far? Any question regarding to problem how to draw a plot graph or something else? So far, okay? Uh, okay, good. Okay, after we get all these things, okay, so we want to identify which one is a break-even point, or we call it as a BEP. Okay, in order to calculate or in order to find out what is a break-even point, so we have to first look at on the line here. Is it any intersection between line A or line B or line C or line D? Okay, the first thing, okay, we look at on the first line. This is line A. Is it any intersection in between other lines? So we will see on the line A intersection with the line B first. So intersection here, so we draw here and we will get this is A base. The point number will be 6.25. Okay, the first intersection, okay, between line A and line B. Another thing is we look at on the another intersection line. So we find out that intersection line between B and also the C. So cross line here. So we will get 14.3 thousand of the units. So this is a B base. And the rest is the C base. There's no line. So only two line has been intersection between line A and line B, and line B and line C. Okay, this is based on our graph. Okay. Uh, so how do we calculate the break-even point for the A or for the B? So we look at on the graph plotting here and find out the intersection between birth line and then cross line here. Then we can read the value for the Q, thousand of the units. Okay. Uh, how we want to double check or double confirm, is it our answer is correct or not? Ah, okay, so in order to calculate, in order to prove that our answer based on our plotting graph is correct or not, we can also do the sum of the calculation or linear trend equations. Okay, for example, line A equal to line B because intersection of line A and line B. So put all these our formula TC equal to VC plus FC times to Q. Okay, and then we will find out what are the Q numbers. So after calculation, we find out that the our Q, okay, will be same goes to be this one. Uh, so meaning that our answer is correct based on our plotting graph, based on our calculation. Okay, good. And meanwhile, for the line intersection between B and C, so we can assume B equal to the C line. So we put all the formula here and we found out the Q. Okay. So we will get the answer 40,286 units. Okay. Which is proof that our graph is 40.3 thousand of unit. So correct answer. So they have two types. Okay. In order to calculate the break-even point or break-even quantities. Okay. So in examination, during the examination, if you are able to plot a graph, okay, and then you have to find out based on the break-even points, and in order to double check, is it the break-even point is correct answer, so you can calculate based on our linear trend equation. Okay, A equal to B equal to C, and then double check. Is it correct? Okay, good. So we will correct answer. Any questions so far for the break-even analysis? No? Easy, right? Okay, Alhamdulillah. Good. Okay, so far any question? Okay, please. Any question? I need a question. Uh, no question? Good. This
Okay,
session
it's
very
okay.
Alhamdulillah. Okay, so we proceed on the next. Okay, so number 2, calculation. Mini sum analysis. Uh, not minion, Doctor, I think chapter 2 is minion and it's not minion, mini sum model. Okay. Okay. When we want to use this mini sum analysis or mini sum method, when we are locating a new facilities, okay, or by minimizing the weighted sum of rectilinear distance from a new facilities to the existing operation activities. So this is how important when we want to use this mini sum analysis. For example, we want to determine the location of photocopy machine in the office. So we can use this mini sum models. Or we want to open the medical clinic or shopping center in new area. So we can using the mini sum analysis. Or to build up the factory in order to replace several small workshop in different area. So we can use also the mini sum analysis. Okay. Okay, this is a formula for minisum approach. Okay, please copy down first. Okay, the formula will be like this. Okay, two types. In order to get the median, okay, so we have a sum of the WI divided by 2. Okay, first time achieved. Okay, later on I will explain. And in order to find out the cost function fx, so we have the coordinate x and y, sum of the wi, okay, bracket here, x minus 2ai plus y minus 2bi. Okay, so what is fx here? Okay, this definition here. Okay, so this is fxy. So the total movement cost within the new facilities and current facilities. Meanwhile, for the WI is a weight of the activities or weight or activity frequency. X star and also Y star is coordinate for the X or Y for the new facilities. And AI and BI. Okay, AI is coordinate for the X for the current facilities. Meanwhile, for the BI is coordinate for the Y for the current facilities. Okay, don't worry about this formula. Okay, later on I will explain based on our examples. Okay. Okay, this example. Okay, please carefully look at on the example. Okay, the first one, determine the optimum location for the new machine. Okay. Okay. Assume that the cost per unit movement are the same for all machine. So this is how the question is look like. Okay, generally, grinding is finishing a process after metal cutting, such as a turning or milling. So the grinding machine will be fixed at the workshop. And 5 location existing lathe or milling machine are M1. Look at M1. Uh, so M1, they are given a coordinate, okay, for the 5 location. So in which coordinate AI or X will be 1. Meanwhile, for the coordinate BI, Y is 1. So look at on this question. Meanwhile, for the M2, machine 2, 5-2. Okay, 5-2, machine number 2. Machine number 3, 2-8. And until the rest, machine number 5 will be 8 and 6. So the number of trip WI they given to you, okay, as shown in this table. Okay, so this is how the question is select for our mini sum calculation or approach. So first one, they are given to you, this is current machine location. Okay, coordinate AI or BI. So AI for the X, BI for the Y. And also, they're given to you a number of trip, WI, 5, okay, 6, 2, 4, or 8. Okay, so the first one, we have to determine what are the optimum location for a new machine. And please remember that assume the cost per unit movement are the same for the all machine. Okay, first one. Okay, this is the current table, existing table. Okay, so the first one we have to coordinate the AI. AI is a X. Okay, so please remember arrange from the lowest value to the highest value. Okay, look at on the coordinate for the AI or X. Which one? Arish, which one we starting from the lowest value to the highest values? Which one the first one? The first one is will be like this. Second like this. 3. And number 3 will be machine 4. And number 5 and number 4 will be 5 coordinate and number 5. So we have to arrange from the value, lowest value to the highest value. So please arrange again. So we look at number 1 is M1. Yes, correct. M1, 1. Okay. So please double check what are the number of trip for M1, 5 here. Okay. And number two is will be machine number 3. Yes, correct. Machine number 3. So what is the coordinate for the AI machine number 3? Is 2. Correct, 2. What is the number of the trips? Look at here, 2 here. So put it on this graph here. And the third lowest value from the highest value. Okay, the third one is 4. Machine number 4. So double check machine number 4. Coordinate for the AI or X will be 4. Number of trip will be still 4. So please put it 4 here. Same goes to be a previous one until you will get M2 and also the M5. So please arrange accordingly from the lowest value to the highest values. Okay, very clear? Please remember this thing. Okay, when we are applying the MINISA models, okay, they have to start arrange the lowest value to the highest values. Okay, any questions so far? Understand? Okay, good. Alhamdulillah. And then this is median. How do we calculate this median first? Okay, this is formula for the median. Sum of the WI divided by 2. So how we get the WI? So WI is a total number of trips here. So in order to calculate total number of trips here, 5 plus 6, 6 plus 2, 2 plus 4, 4 plus 8. So we will get a total number of trips is 25. So 25 here, okay. Okay, we put here 25. Divide by 2. So we will get the median 12.5. So this is our base reference in order to calculate or determine the new X star and new Y star. Okay. Okay. Clear this thing? Okay, clear. Okay, so based on our new coordinate X AI that we are arranged from the lowest value to the highest value, look at on the total WJ. Okay. So how we get to WJ here? Okay, 5 will represent 5. Okay. So 5 plus 2, we will get 7. 7 plus 4, we will get 11. 11 plus 6, we will get 17. 17 plus 8, we will get 25. So we have 5 here. Okay. We have 7 here. We have 11 here. And 17 here. And lastly, we have 25. This is how we calculate the sum of the WJ. In order to determine the X star, okay, so please look at on our median. They're given to you our median. Median must be 12.5 based on our calculation previously. So 25 divided by 2. So we'll get 12.5. So please find out, okay, based on sequentially. First come, first serve. Is it more than our medians? 5, is it more than our medians? No. Okay. 7, more than 12.5? No. Is it 11, more than 12.5? No. Is it 17, more than 12.5? More than our median? Yes. Is it 25, more than our median? Yes. So which one the first come, first serve? First come, first serve will be machine number 2. So please remember, please write down first come, first serve. First come, first serve. Okay. So when we look at on the first come, first serve, okay, so we look at more than our median. So meaning that we put here the new for the location X star will be 5. Very clear? Okay. Any questions so far? Okay. I hope all of you fully understand and will get full mark in test number 1. Okay. Okay. So we calculate our coordinate Y, BI. Okay. Look at OBI. Okay. Then please remember, arrange from the lowest value to the highest value first. So which one the lowest value first? Number 1, M1. Second, this is second. Third one will be here. Fourth one will be here. And lastly, number 5. So please arrange to our BI here. Ah. So we will get M1, M2, M4, M5, M3 based on our arrangement from the lowest value to the highest value. So 1, 2, 4, 6, and 8. Okay, and please follow the number of trip based on our machine. Okay, if you machine number 1, a number of trip is 5. If a machine number 3, the number of trip will be 4. If a machine number 5, okay, the number of trip will be 2. So please follow based on the machine. So put here. Okay, clear? And then how we want to calculate this sum of the WG? And same goes to be previous one. 5 will be 5 here. 5 plus 6 will be 11. 11 plus 4 will be 15. 15 plus 8 will be 23. And 23 plus 2 will be 25. And look at on our median. We will get median is 25 again. I repeat again. So we will get 12.5. So please find out which one is more than. Is it 5 more than 12.5? No. Is it 11 more than 12.5? Still no. Is it 15 more than 12.5? Yes. Is it 23 more than 12.5? Yes. And 25 more than 12.5? Yes. So which one we want to select? Whether machine 4, machine 5, or machine 3? So we will select on the first come. Please remember, first come, first serve. Okay. First come, first serve. So first come, so we will get the value machine number 4. So the new coordinate for the Y star will be 4. Clear? Okay. So therefore, we have to find out, okay, the optimum location for the new machine will be YX star, and Y star will be 5 and 4. This is how we determine the optimal location for a new machine. So please remember, okay, the first one, range for the lowest value to the highest value. After that, you will get the first come, first serve, okay, for the more than our median values. Okay, so how about the calculation of the cost for the optimum location? Okay. So you find out the new optimal location X star, Y star is 5 and 4. So please put it here. And please apply this formula previously. Okay. Formula will be this, like this. This is convention. Okay, please apply this formula into this question. Okay, so 5 star. Okay, 5 star, still 5 star. Okay, 5 star. Okay, 5 here, 4 here. How we want to calculate 5 here and 4 here? Okay, please double check. 5 here is here. 4 here is 4 here. Okay, so the number of machine number 5. Okay, 1, 1. Machine number 1. 1, X, 1 is Y. So put it here. 1 and also D1. And times 2, 5. Okay, plus 6. Okay, why 5? Why? Because a number of trips. Same goes to be 6. Okay, number of trips. 6 will be here. Same location, X star, Y star here. 5 or 6. And look at on our 5 and 2. 5 and 2. Put it here, 5 and also the number 2 until to the rest. So you will get the cost for the optimal location 105. Okay? Any questions so far regarding to how we want to calculate the cost optimum location? Any confusing between our calculation, which one we want to locate the optimum location? So this is based on our formula, okay? So if 2, double check what again, coordinate for the AI is 2, coordinate for the BI is 8. So please, 2 here, 8 here. How will you get a 5 and 4? Based on our new optimum, X star and Y star. So we will get a 5 and 4 here until to the rest. So we'll get the cost for optimum 105. So if the cost is 1 ringgit 50 cent per distance, so we have to calculate what are the minimum costs. So 105 times to 1 ringgit 50 cents. So we will get 157.50 cents. This is a total cost for Minisum. Okay, clear? Any questions so far? Uh, no question. Okay, Alhamdulillah. I hope my student will get 20 mark and above uh, out of 30 for the test number 1. Okay, hopefully. Okay. Okay, this location can also be determined by plotting a graph, okay, versus AI, FB versus BI, okay. The optimum point is located at the lowest curve, okay. So this is additional information. Okay, done for our Minisum model. Okay. So recap again. The first one, what the type of the calculation in our physics planning? The first one, we call it as a break-even analysis. Okay. The second one is a Minisum model. And last but not least, the third one. This is a location transportation model. Okay. When we want to use this transportation model, so we want to find the lowest shipment cost for distributing products, good or supply, from multiple supply to multiple destination of demand. So this is how we are going when we are to use this transportation method. Okay, please listen carefully. Okay, this is very important. Okay, this is example. This is figure 1. Okay, the transportation problem. Okay, involve determining the minimum cost of plants for shipping from the multiple sources to the multiple destination. Let's say, okay, this is a supply 1. Okay, this is supply 2. Supply 3. Let's say supply 1 located in Parit Raja. Okay, for example. Supply 2 located in Air Hitam. Air Hitam. Okay. And supply 3 located in Batu Pahat, for example. But demand 1, demand 2, demand 3, demand 4, for example, demand 1 located at Parit Solong, for example. So we found out nearest from UTSM. Demand 2, UTSM, for example. Demand 3 will be Keluang or Taman Keluang, for example. Demand 4 will be at what we call it Sri Gading. Okay. So I give it to you. This is supply, okay, the manufacturers, and this is demand. So for example, if we want to supply a demand from Parit Sulong, which one the supply 1, supply 2, supply 3 nearest with the Parit Sulong? Which one? Parit Raja or BP or Air Hitam? Which one the nearest one with demand 1?
Batu Pahat.
Batu Pahat. Okay, that's it. Okay. And demand 2, UTSM. Which one a supplier or what we call it manufacturer can be supplied for UTSM? Demand number 2. Parit Raja, Air Hitam or BP? Parit Raja. Can cut down the cost of transportation first. Okay. If lack of the demand, okay, if there's no what we out of the stocks, we can supply taken from our second nearest. Which one the second nearest? Air Hitam or Batu Pahat? Near with UTSM.
Hitam.
Air Hitam. Yes, correctly. Air Hitam. Okay. This is how we call it transportation model. And also the demand tree Keluang. Okay, to Keluang, the nearest one is Air Hitam. Okay. Or Sri Gading, the nearest one is whether a Pahit Raja, right? Pahit Raja. Okay. Batu Pahat can also demand. Okay. Number 2. Okay, this is how the transportation model is look like on the supply chain management. But in transportation model, we want to determine a minimum cost plan for shipping, okay, from multiple sources to the multiple destination. Okay, look at on the example. This is a row, okay. Okay, first thing I will show first. This is our row, okay. This is our column. Uh, So in any examination, they are giving to you these things. Okay. The first one, okay, I will look at first thing. Okay. Oh, sorry. Okay. The first one, okay, look at on this table first. Understand how the table for the transportation model is look like. Okay. The first one, we also have the warehouse. Warehouse, okay, or supply here consists of warehouse A, consists of warehouse B, C, and D. And this is supply. Uh, Meanwhile, for the factory in column, this is what we call it in column. Column warehouse A, warehouse B, warehouse C, warehouse D. Warehouse in column. Meanwhile, for the factory is row. Factory number 1, look at the row 1. Uh, Factory number 2, look at the row number 2. Factory number 3, look at on the row number 3. So this is a demand. So in order to get a balance, okay, total supply capacity, okay, total supply demands, quite balanced. So we will get a number of balance will be balanced here. For example, this is 450 total supply capacity per periods. Okay, can supply, total supply. Meanwhile, this is 450 total demand per periods. So this is factory by demands. And this is supply by total supply. Okay, must be same value. Okay, and each of the box here, the small box here is represent about the cost to ship one unit for factory 1 to the warehouse A. For example, okay, we want to determine whether how the cost, okay, for example, this is a ringgit Malaysia, for example. The cost to ship one unit, okay, from factory A to the warehouse A, okay, factory A, okay, please remember, factory A to warehouse A. So the cost will be 4 ringgit Malaysia. Okay, this thing. If we want to determine the cost for the from factory 1 to warehouse B, 7 ringgit. From factory 1 to warehouse C, 7 ringgit. For warehouse factory 1 to D, 1 ringgit. So it depends on whether a factory 1, factory 2, factory 3. Whether we want to go warehouse A, warehouse B, C, or D. Okay? Understand? Okay, correct. Okay, wait. Okay. I erase all this thing. Okay, clear this thing. Okay, so we want to determine what are the minimum, okay, the lowest cost, Okay, the first one, okay, wait, okay. Okay, look at the example. The first one, we want to determine which one the lowest one. Okay, look at on the small box here, okay, in between 4 ringgit, 7 ringgit, 7 ringgit, 1 ringgit, 8 ringgit here, 3 ringgit here, 8 ringgit here, 10 ringgit, 60 ringgit, or 5 ringgit here. Which one the lowest one? 1 ringgit, right? So we can put the first one is 1 ringgit first. This is number one. This is number one first. So how we want to locate the supply? Look at on our box supply 100 here, and look at on our demand 160 here. In between 100 and 160, which one have a low minimum? Supply 100. So we put it on the 100 here. Okay, so 100 minus 100, so the balance will be 0. And look at on our column here, okay, and the row here, okay, for the demands. So 160, okay, minus to 100, what we will get? Okay, 60, right? So they have balance 60. Okay, for example, a balance is 60. So we can put on 100, 60 minus 200. So we will get 60 here. Okay, for example. Okay. Okay, this is the first one, lowest one. Which one the number is second lowest? 3. Yes, 3. So look at on our row and our demand. So our row here is 200 and our demand will be 90. So which one have a minimum? 90 or 200? 90. Okay, correct. So we put here 90 here. So if we put here 90, what a balance current here? Okay, wait, what the current balance? Okay, later on we discuss. 90 minus 90, we will get 0. But 200 minus 90, we will get 110. 110. Okay, balance. So this balance is 60. Okay. And which one? This is number 2. Number 2 lowest. Which one the third lowest value for the cost to ship? Which one? 4. 4 or 5? 4 first. But when we look at on the 4, there is no supply here, hundreds. Okay. So we move on the next, second or third lowest one. So it will be number 5. Why? Because there is supply 0 here. In our row here, we cannot put any units in order to supply because the balance still 0. So we want to find out which one a balance, they have still a balance. So the 5 is number 3 first. Okay, so number 3. Okay, so look at on the balance. Okay, what is the balance we have here? 60. So put 60 here. 60 minus 60. So you will get 0. Okay, so 60 here. 150 minus 260. So what will you get? 90 balance here. Okay, this is step number 1, lowest. And the fourth one, after 5, which one? Which one after 5? So we found out this one first, 80 first. Number 1, 8. Okay, this is number 4. Okay, so 80 minus 280, so we'll get 0 balance. And please remember here, we have a balance 90 here. 90 minus 280, so we get a balance 10. Cross here. And which one? What we call the fifth lowest one is number this one, 8. Because we have balance 110 here. So put 110 here. So 110 minus to 110. Okay, so we'll get 0 balance. Okay. And 110, 120 minus to 110. So we will get balance tens here. Okay. And last but not least, okay, which one after 8? 10. 10 cannot be because the balance is 0. Still 10 here. So we found out 16 here. So until here we'll get, so 110 plus 10, we will get 120. Okay, so minus with 120, so we will get 0. So this one, 10 minus 10, we will get 0 again. So until we balance all these things, supply will be 0 and demand for the unit will be balanced is a 0. So that's it. We have to calculate. How do we calculate? Uh, this thing for the demand from the warehouse. Okay. This is how it look like. Okay. Oh, sorry. Okay, again, Okay. So after you get all this plotting in this graph, okay, please put it on this hour, each of this hour graph. Ah, okay, one by one. So 100 unit, okay, times to 1 ringgit Malaysia, plus 90 units times to 3 ringgit Malaysia, plus 110 times to this one. And then until you will get the answer here. Okay. So you will get the total for ringgit Malaysia example. 2,350 ringgit Malaysia. Okay. Understand? So don't be confused. Find out.
Doktor,
Yes. Any
boleh
question?
tak kena repeat balik yang table tu? Saya pening-pening lah doktor.
Pening kan? Tak apa.
Pening lah.
Jangan risau. Saya akan tunjukkan satu lagi contoh. Okay. Copy down first. Copy down first table ni. Baru rasa pening tadi kan? Tadi rasa tak pening belum telan Panadol tu rasanya. Salin this first copy down first. Okay, this is a question. Second example, I give it to you. Okay, please copy down this table first. Okay, they have a plant here, Peony Atlanta. Okay, and also the warehouse 1, 2, and 3. So they got the cost of shipping. Okay, 5 ringgit. Okay, from Peonic to warehouse 1, 5 ringgits. From plant Peonic to the warehouse 2, 6 ringgits. For warehouse from the Peonic plant to the warehouse 3, 5 ringgit 40 cents. And then the capacity we given to you 400 here. And Atlanta 500. So total for the capacity is 900. Same goes to be a requirement or demands. Okay, warehouse demand 1 is 200. Okay, warehouse for demand 2, 400. And requirement for warehouse number 3 is 300. Total 900. Okay, this one very clear. Please understand the question first. Okay. Done? Copy down? Okay, so please listen carefully. Okay, the first one. Okay. Okay, find out which one they have the lowest. Identify first one, the lowest cost cell. In between 5 ringgit or 6 ringgit. Okay, wait. I use my laser pointer. Okay, 5 ringgit, 6 ringgit, 5 ringgit 40 cents, 6 ringgit 60 cents, and 4 ringgit 60 cents, and 7 ringgit. Which one have the lower sell, lower cost? 5 ringgit, 4 ringgit 60 cents. This one, the first. So we put, look at on the our requirement and look at on our capacity. Our capacity 500. Our requirement 400. In between 400 and 500, which one have a lowest minimum numbers? Will be requirement, right? Okay, put the requirement here, 400. 400 minus 400, so the balance will be 0. Understand? Meanwhile, for the 500 minus 400, so the balance will be 100 left. Okay, clear? Okay, good. Any questions so far? Okay, clear? Okay, second things. Which one the second lowest cost in our table here? Which one?
RM5.
5 ringgit. Macam nak beli puzzle je, 5 ringgit. Mau tabak contoh 5 ringgit. Okay, 5 ringgit here. In between 200, okay, look at on our requirement in this column or this row, and this what we call it capacity. In between 400 and 200, which one have a minimum value? 200. So we put 200 here. So 200 minus 200, we will get balance 0. 400 minus 200, we will get 200 balance for the capacity on the Pionic plan. Okay? Understand? Clear? Nur Hafiz? Okay, Nur Hafiz? Okay. Which one the third lowest cost value? Which one? 6 ringgit or 5 ringgit 40 cents?
5 ringgit 40 cents.
Okay, look at 540 cents. Okay, in between 300 and between 200 balance here, which one have a lowest value? 200. So put here 200. So 200 minus 200, we will get 0 balance here for the capacity Pionics. Meanwhile, for the requirement, 300 here minus 200 here, so we'll get the balance 100 will be here. Okay, clear? Alhamdulillah, good. Don't worry. Okay. And which one the fourth lowest cost cell? Any balance here? Okay, so we move here. Lastly, we will get 100 here. Okay. So 100 here and 100 here. Okay. Okay, this one thing. Okay. So 100 minus 200. Look at 100 here and 100 here. So still 0. 100 minus 100, we will get 0 balance. 100 minus to 100, we'll get 0 balance. So we put on 100 unit here. So we'll get, please double check on our capacity. Okay, on our capacity is 0 balance, 0 balance. Okay, and we get 900s. In meanwhile, for the requirement, 0 balance, 0 balance, and 0 balance, still 900. So we'll get on this table. Please put in all these things, value, insert in order to calculate the total cost. Okay, put it here. 200 unit times to 5 ringgit, for example, plus 200 times to 5 ringgit 40 cents, plus 400, okay, times to 4 ringgit 60 cents, plus 100, okay, times to 6.60 cents here. So the total cost that we'll get for this answer is 4,580 ringgit. Understand? Clear? Very easy, right? Alhamdulillah, good. So please double check again. How do we want? Please find out what are the rule of thumb in order to calculate this transportation method. So we need to find out the lowest cost for the each of the we call it as a small cells. Okay, then we have to sequence based on our lowest to the highest until we get a balance for the capacity and requirement must be 0 balance. Okay. Okay, so please double check again. This is our transportation model. So please remember, okay, in this our calculation and this topic, okay, cover 3 type of the our calculation. For example, we have a break-even analysis, okay, and also we also have the mini sum model. And third one, we also have the facility. We have a transportation model. Okay, so only these 3 type of the calculation that important. Okay, in order to you have understands how we want to select the cost of facility location effectively using three type of the different equation. Okay, we move on the next facilities layout. Okay, this is just on the theory. So we need to find out what are the layout type of layout in our facilities, especially for the production line. Okay, for the manufacturing industry. Okay, look at one by one. What is facilities layouts? Okay, facilities layout is developing a facilities layout is critical step in order to facilities planning process. Okay, correct. Okay. And then facilities planner must be creative and comprehensive in generating layout alternative. So in order to design the facility layout, it involves with facilities planner, involved with engineers and other person in charge. And material handling system, or we call it MSS, or facilities layout, which one come first? Which one? Which one do you think come first? Material handling system or facilities layout first? The first one is facilities layout first. Then we put the material handling system in our layout. Okay, so there is no material handling system first. Okay, and then come up with facility layout. The first one is layout first. Then we put anything on our system, including the material handling system. Okay, so layout is influenced with by centralized with versus decentralized. Storage of WIP, okay, tooling or supplies, okay. Please double check again. Must be centralized versus decentralized, okay. And then number two, we want to fix path versus variable path handlings, and we want to look at on the unit load size. And we want to look at whether it's automation, manually or semi or fully automation. And last but not least, we also have to differ by the level of inventory, control of the material itself. Okay, so handling less is the best frequency of material are handled. Okay, but it's not necessarily the handling distance. So layout or MH first, birth. Okay, consider a number of alternative handling system and compressing layout the alternative. So when we are looking on the layout design, so birth is very important. But the first one, look at on the layout. What type of the layout where we have? Then we design the material handling system first. And this is layout design alternative. Okay. The first one, okay, we want to design based on our facilitate entertainment of the product or service quality. Okay, look at consideration in order to design a layout. The number two, we want to use a worker and space efficiently. Okay, avoid a bottlenecks. Number three, minimize unnecessary material handling costs. Okay, and eliminate unnecessary movement of worker or materials, and minimize production time or customer service time. And last but not least, we want to design for the safety. Okay, this is how the objective if we want to design the layout. And important of layout decision. Okay, the first one, we have to require substantial investment of money and effort. We want to involve the long-term commitment and have significant impact on the cost and efficiency of the short-term operation. This is important, how we want to making addition for the layout designs. And the need for layout decision is efficient operation. For example, high cost bottlenecks. This is must be high cost. Changing in design of product or service. Okay. Introduction of new product or service, or any accident or safety hazard related, especially for the occupational safety and health issues. So this is how we want to need the layout decision, whether we want to redesign again, we want to changing the layout based on our factors here. And also the change in environmental or other legal requirement, okay, especially for the law, okay. Changing in volume of the output or mix the products, or change a method or equipment, okay. For example, if we are using The low technology, for example, we are using a CRT monitor. Okay, nowadays we are using LCD monitor. So changing of the technology, changing of the method and equipment. So we need to redesign layout again. And last but not least, also the moral problem. Okay, so we want to tackle this problem in order to design the layout. And what is a layout? Okay, the configuration of department, work center, equipment with particular emphasis on the movement of work, especially for customer or material through the system. So this is type of the layout that we have, okay, in facilities. Number one, we also have the product layouts. Okay, number two, we also have a process layout. Number three, we also have a fixed position layout. And fourth is a combination berth layouts. So we look at one by one. So this is basic layout. Okay, what is a basic layout? The product layout, number one. What's the product layout? Utilize a standard processing operation to achieve a smooth, rapid, high volume flow. Meanwhile, for the process layout is able to handle variety of process requirement. And meanwhile, for the fixed position layout is a product or project remain stationary. And whereas the worker material equipment are moving where needed. For example, we are making a car. For example, we are making a aircraft. We are making a bus. So we need to this fixed position layout. They still keep remain where workers or material equipment are moving where into their parts. Okay. This is example product layouts. Okay. So you can see here raw material or customer, they have a station number one, they have process of number two, station number three, station number four, until to finish item. So each of the station, they have their own material or label. Okay, for example, label here. Okay, so every station, they have a label here. This is what we call it a product layout. Please remember how to define the product layout sequence. Okay, utilize standard process operation, achieve smooth, rapid, and high volume. For example, this one, making box. Okay, okay. After making box here, this one entering the product into the box. Okay, put it here, and this one wrapping area. For example, station wrapping. We are using a plastic wrapping. Wrapping here. And the fourth one is QC. QC, for example. So this is how the station is look like. After station number one goes to be station number two, station number three, station number four, until a finished item. This is what we call it as a product layout. Okay, what is a product layout? You can see here, used repetitively on continuous processing. Okay, so why they call it as a repetitively? In ergonomic term, repetitively motion is one of the issue, one of the ergonomic hazard or risk factor. So for example, if this worker, Abu, for example, performing this work from 8 a.m. to 6 p.m. Okay, so one shift. So they are repeating again and again using same muscle, same tendon, same work task, same movement in order to this fix at the workstation number one. So the repetition can cause of the serious problem, such as ergonomic issues. Okay, so repetitively, for example, packing or this product box for one day might be 236 box per day, per shift, for example. Uh, so please imagine that this worker Abu have repeating again and again same motion with 260 times performing a box per day per shift. So can you imagine how many weeks, how many months? So we can calculate time per weeks. Okay, time per day. 1 week, 7 days. Okay, time per 7 days. Okay, per week, or times to 30 days per month. So this is repetitively or continuous movements. And look at on the sequence. Okay, same goes to be like this. Operation number 1, raw material. Number 2, operation number 2, body fabrication, wheel assembly, door assembly, stock distributing. So they have a here, operator will be here. Some operator, fabrication of the body here. Okay, this is operator. Might be 1 or 2 operator performing repetitively job tasks. Okay, every day. And this is what we look like for our receiving. For number 1, this one. Okay, number 2, 3, 4 is material and component layouts. Receiving stagings first, and goes to be on the our sub-assembly feeder lines, and they have a put of storage here until to oven here, until last storage and shipping. This is how the product layout. Okay, so please give me any example product layout based on your experience. Okay, can you name it? Any product layout that you've seen based on your experience? Can you give some example to me, Zuhelmi? Any? Give me one example product that follow on the product layout. For example, if we are making keripik pisang.
Yes.
Oh, okay, potato chip lah, okay, banana chip lah, okay. Yes. We want to goreng okay, fries first, and then we want to cutting first, and then goreng first, and packaging first, and then distribute to our agent or in our shop lah, for example. Okay, this is product layout. Okay, so same repetitively. Okay, advantages of product layout. Okay, this is advantages of product layout. We can see here the first one, high volume production, high production rate. Yes. Okay, can produce many units, but low cost per units. Okay, per products. Okay, only using a labor. Okay, one labor or two labors. Low cost in material handling. Okay, high utilization of labor equipments. Labor specialized. Specific work. For example, this is what we call is station number 1. This worker have their own skill. For example, SKM level 3. But about the machining, for example, this is machining process. Okay, this is machine. So can specialize, expertise in this field, in this operation. So this is how the advantage of product layouts. And establish a routing and scheduling, okay, schedulings for this workstation. Okay, the advantages of using product layout. What is these advantages? Okay, as I mentioned earlier, okay, the advantages of the product layout is a repetitive job, can cause of the ergonomic issue. Okay, so what is ergonomic issue? Suddenly for 1 hour continuous work, can cause of body discomfort, especially for the back pain, lower back, okay, neck pain, hand wrist, or we call it the carpal tunnel syndrome, due to repetitively jobs. Okay, and number 2, low skill worker may not maintain quality of the output, impair quality, because this worker only focus on specific work tasks. Okay, for the same work task for almost at least 10 years or 20 years or 15 years. Okay, do the same process again and again. Okay, no flexible to change in volumes. Okay, focus on that specific job task, impair output rate when breakdown or shut down, and preventive maintenance is critical. Okay, so for example, I give it to you example, don't worry. This is example station number 1, this station 1, this station number 2. Okay, so station number 1 only involve a machining. Station number 2 involve a packaging process, for example, transfer from 1 and 2. When this machine has been breakdown, there's no preventive maintenance. So we want to focus preventive maintenance, okay, for all this machine in order to keep Okay, this station or workstation continuously operation. Okay, if there's breakdown here, we can operate from the section 1, section 2. So section 2 will be waiting for the longer time to waiting until the preventive maintenance has been implemented on the station number 1. Okay, this is why the advantage using a product layout. And meanwhile, the process layout. This is process layout. Department A is stamping. Department B lead. Department C milling. Department D grinding. E etching. And F is a coating. So look at on this our figure here. Job A, job B done. Okay, here come here. Okay, this is process layout. Okay, so this is job planning. Okay, this is workstation 1, pattern shop. Workstation 2, fabrication. Workstation 3, assembly. Wiring, workstation 4. Workstation 5 is test. And workstation 6 is shipping. So this is how job A done first. And go to B, workstation 2, 3, and until A. Meanwhile, for the job B, go to workstation 1. And go to workstation 3. And goes to B, workstation 4 until to the test and the end for the B. So this is process layout. Okay. And use of for intermittent processing, job shop or batch process. Okay. So this is example. Okay, able to handle variety of process requirement. So let's say there is a saw here, lathe here, milling here. So also have a lathe here, milling here, grind here, weld here. So we can, from the saw, can go to lathe here or can go to the lathe in here. So it depend on the variety of process requirement. So it is process layout. Okay. And then the lacking for using this process layout is use intermittent processing and job shop and batch processes. So looking on the advantages using this process layout. Able to handle variety process, okay, requirement, okay, not affected production rate when machine a failure, low cost in equipment utilizations, and possible to create individual worker incentive plan. So it might be, can be changing from the workstation 1, workstation 2, can be rotate, job scheduling, job rotation, okay, for each of the process. The advantages is this process layout in process inventory cost can be high, changing routing or schedulings, equipment utilization rate are low, material handling slow and efficient, complexity, often when reduced span of the supervisions, and special attention for each product or customer. So these are advantages using a process layout. And last but not least, accounting and purchasing are more involving in this process. Okay, meanwhile, for the fixed position layout, this is real world, large construction project. For example, we are manufacture the aircraft. Okay, there are two type aircraft. Okay, so this is a aircraft that we have to using a fixed position layout where the aircraft is maintained centralized here, and the move is only a worker based on the part that we need to assemble. So nature of product that involved in our fixed position layout is a weak, size, and bulky. Okay. So for example, a car manufacturing, for example, a bus, a commuter train, and something like that. Okay. And this is how the definition conceptual for the our fixed position layouts, where this is centralized. The other operators such as drill, milling, grinding, assembly, painting here come into a center, do their job in order to complete one of the products. Okay, this is how they look like. Aircraft manufacturers. And improve layout by using word cell. Okay, noted here, when we are designing our layout, please make sure we are using a U-shaped work cells. Okay, why we using U-shaped work cells can reduce material and employee movement. Okay, by performing U-shape may also reduce a space requirement, enhance communication, cut the line number of worker and make inspection easier. See example, a current layout will be like this. Okay, worker in small closed area cannot increase output without a third worker. Okay, for example A. So improved layout will be like this. For example, this worker only focus only this area. Worker 1. Another worker number 2 only focus that particular area. But we improve the layout, worker can be assist each other. Might be able to add third worker. So might be number 1 and number 2 can be rotate here, and number 1 can be rotate at number 2 area. And if possible, we can add on another number 3 workers here. So you can see the improve when we are implementing the U-shaped work cell. Same goes to be like this. The current layout, straight line. You see this straight line here? Okay. So involve 4 workers. 1, 2, 3, and 4. Okay, and balance task because worker might not able to divide task eventually. Somehow worker number 4 move here. Somehow worker number 2 move here. Some of the worker number 3 will be moved here. Because they're not able to divide tasks eventually. Okay, and we improve here. Look at on this here U shape. Worker have better access, and 4 worker were reduced to 3 workers. From using 4 workers here, we are using 3 workers only here. So can be divided. For example, this worker involve this area. This worker involve this work area. And another worker involve this work area. So focus on that particular workstation or work unit. This is how if we want to improve layout by using a U-shaped work cells. Okay. And U-shaped production is look like this in and out. Okay, same as previously. And cellular layout. What is cellular layout or production? Layout in which machine are grouped into a cell that can process items similar processing requirement. Meanwhile, for the group technology is grouping into part families of item with similar design or manufacturing characteristic. So we look at on the example. Any example here? Okay. So what is the differentiate between a functional and versus to cellular layout? So based on our dimension here, there are many number of move between a department for the functional, but only a few number of move between department from the cellular. And travel distance might be longer for the functional, and meanwhile for the cellular might be shorter for the travel distance. And travel path variable for the functional, and cellular will be fixed on the travel path. And with the others thing, so you can see job waiting time greater versus the shorter, throughput the time higher versus the lower ones, and supervision difficulty must be functional higher than compare with the cellular with a lower supervision difficulty, and the other things. Okay. Such as scheduling compatibility, equipment utilization, and others. Okay, we look at on the example. This is service layout. From the truck here, we have also a conveyor here. Okay, we also have zone 1, zone 2, order pick here. This is most what the service layout that you might be seen in our what we call it is delivery and transportation. Okay, for example, JNT, okay, Post Laju Malaysia, DHL, GDEX. Okay, so they have a using a service layout. So the service layout is a warehouse or storage layout, a retail layout or office layout. Okay, so it depends on our service type of the products. Okay, and service layout must be essentially pleasing. Okay, so must be take into account on the safety and harm, must be designed in proper on the ergonomic issues and other anything hazards. Okay. That's all for the class today. Okay, anything question you want to ask? Okay. Okay. Ada soalan tak nak tanya? Anything question? There is no question so far? Okay.
Sir,
Yes.
nama saya belum update lagi di dalam Mata, sir.
Lama lagi belum update dalam outer Okay, nanti saya
sir.
minta. I will inform the coordinator to update your name to be listed in our TCIS. How many of you yang tak update lagi nama? Ada lagi tak? Tak ada? Clear Okay, for the group project, okay, nanti saya akan divide you all members based on the group project, based on the section. So later on, I will update at the group WhatsApp. Okay, so look at on the group WhatsApp. Okay, later on. Okay, first I want to stop recording first. Okay.